Hello, this is Professor Rios again. We're going to review electrical circuits, and when it comes to that, we're going to review um, parallel circuits. Now, when two elements are in parallel, two elements are in parallel when they carry the same voltage and different current if the values are different. On the other hand, with series circuits, what is particular about those is that all elements carry the same current and will have different voltages according to their actual value. These are series calculations, series circuits, power calculations. To do the power, you only have to remember two formulas. The power is equal to voltage times current and resistance times current to the square value. So there are sometimes different ways to solve an electrical circuit involving voltage, current, and resistance and power. The total resistance is equal to the sum of all resistances. Current remains the same, and the VD is of all is equal to the voltage source. So the individual voltages is equal to the voltage source, and the total power is equal to the sum of all the powers also. Now, series connected power supplies. When power supplies are connected in series, the voltage of power supply will be additive, provided the polarities are connected properly. That means that the voltage of the power supply is the same as the voltage delivered to the loads. Series connected power supply, like batteries in this case, you add the values, okay, and these batteries, for example, are 1.5 volts. You have four. You have a total of 6 volts. Series connected power supply. 3 transformers connected in series form the basis for the delta connected transformer. Now let's see parallel circuits. Parallel circuits are elements where there is more than one flow of current. Therefore, the voltage is the same for both of them. In this case, these two resistors are in parallel because they have the same voltage and they carry whatever current they need to carry according to the resistance. But the most important thing is that the voltage is the same. Receptacles. When wire receptacles on a circuit, they are connected in parallel with each other. Lights. Lights are connected in parallel to each other also. If any branch is open, the power supply continues to provide voltage to the remaining part. As you can see, all receptacles are connected in parallel. Lights are connected also in parallel. If one of the lights goes out, it will continue providing power to the rest. Practical uses, lighting in panel. So here we have branch 3, branch 2, and branch 1 for parallel loads. An advantage of parallel circuit is that any part of the circuit is open, the remaining portion of the circuit is still operate. Like, for example, that light switch 2 is open, the light turns off, but the energy is still being provided to excuse me, branch 1 and branch 3. Practical uses of parallel circuit is basically alarm systems,